So in this chapter, we are doing the graphing of functions, and the last lesson we have done increasing, decreasing, where the graph is going up, where is going down, and the point between increasing, decreasing is what we have discussed before. That is a local minimum or maximum at where the f prime equals 0. And f prime equals 0 or f prime doesn't exist where the c value, the x value, we call it critical point. So the definition of critical point is f prime equals 0 or f prime undefined. And the x value make f prime equals 0 or make f prime undefined. Those x values are the x value for critical points. So we sub in the x value to f prime x. We have x comma f bracket x. This is a point. We call this point is critical point. So C, F, C. And the C value is f prime C equals 0 or f prime C undefined. So these are the definitions for critical points. So from the graph, this is f prime is from left to right is going down, so it's negative, is decreasing. From left to right, this part is going up, is increasing, and at this point f prime equals 0. And left is negative, right is positive. We have a local minimum at this point. The f prime is changing the sign. And from here, the left side is increasing, right side is decreasing. So at this point, f prime c equals 0, and at this point is a critical point, and it changing from positive to negative for the first derivative. We have a local maximum there. And also we have two graphs. So at this point, you will see the f prime, the slope of the tangent is 0, but the left to right is going up. From left to right, it's going up. So the first derivative, the slope, is not changing the sign. So at this point, we don't have the local maximum or minimum, but this point, we still call it a critical point. So another one is here. This is a tangent line. The slope for this point is infinite. It's undefined because the run left to right is 0. So right over run is undefined. And this one, no up or down. So rise is 0 divided by the run is 0. So this slope is 0. This slope is infinite. So either the slope is 0 or the slope is infinite, undefined. We call them the critical points. So in this lesson, we are going to study critical points to find the relative maximum, relative minimum. Then it helps us to graph a function in the future. So all the lessons are preparing us to graph a function. And the maximum minimum points in the integral, so it means not including the endpoints. If ignore the endpoints, the maximum minimum always occur at critical points. But critical points may not always give you the maximum or minimum value. This one no maximum minimum here. So the steps to determine the relative maximum minimum value, we have done it before, is find the first derivative equals 0, but also we need to find undefined. It means it's something divided by 0. So both we call the x value at that point is a critical point. So use this f prime of x. We analyze its increasing, decreasing. So this is a decreasing, increasing, this one increasing, then decreasing to determine its local maximum or minimum. Then step 4, we just calculate the value. So CFC, then give you the points. So first 3 steps, we are looking for the C value to make F prime C equal 0 or undefined. Then we sub in to the function, we find the points, then that is what we are going to do for today. So let's see example 1. For the function f at x equals 2x cubed minus 6x squared minus 6x plus 12, determine all values of x such as f prime at x equals 0. And after that, determine its local maximum. Local maximum means positive and negative for the derivative. Local minimum, so this one decreasing, this one increasing, the derivative at this point, left is negative, right is positive. So we can draw the chart again, or neither for the function. So step 1 from our steps is find the first derivative. So step 1, that is what we are going to do is finding the first derivative. And this is a polynomial function, so we just apply the power rules. So this one is 2 times degree to the front, then the degree subtract 1. 3 minus 1 is 2. Then minus 6 times degree to the front, then the degree take away 1 is 1. So minus 6 times 1x, 1 minus 1, no degree means 1 is 0. So x to the exponent 0 is 1, so no x left. And constant x to the exponent 0, bring 0 to the front is 0 times is 0. So we have 6x squared minus 12x minus 6. So this is multiplication. We could put in the bracket. Then step 2, we want to find f prime x equals 0. So this is still the first step, okay? Let f prime x equals 0, then solve for the critical points. This is no denominator, so we don't have any x value to make the f prime x undefined. So we only have f prime x equals 0. So 6x squared minus 12x minus 6 equals 0. So this is a quadratic equation. We want to do factoring. So first thing, we want to see if we have the common factor. 6, 12, 6 we have. Common factor 6. Then each term divided by 6. We have x squared minus 2x minus 1 equals 0. So for this one, we want to see if it's factorable. And we want to find two numbers times is 1 times negative 1. Then I together is negative 2. So the factor only have 1 times 1. I together is negative, so the larger number equals, it doesn't matter, so one number need to be negative. Time together is negative, so they need to have different sign. Plus 1, positive 1 plus negative 1 give you 0, not negative 2, so it's not factorable. Then we want to use a quadratic formula to find the x value. So that is what we are going to do. We divided 6 to both sides to get rid of this common factor. So 6 divided by 6 is 0, so is 1. So we have 1 times 2x squared minus 2x minus 1. Then 0 divided by 6 is 0. So we have a equals number at front of x squared. No number means 1 times, so it's 1. Then b is number at front of x is negative 2. And the c value is just a constant, is negative 1. So we use a quadratic formula is negative b plus minus square root b squared minus 4ac all over 2a. Then we sub in the a, b, c value, so negative 2 plus minus square root negative 2 bracket squared minus 4 times 1 times negative 1, then all over 2 times 1. Then we simplify. We are going to have x equals negative 2 becomes positive 2 plus minus square root is 4. Then negative 4 times 1 times negative 1 give you 4 all over 2. So x equals 2 plus minus square root 8 over 2. Then for the plus sign, we do the calculation is roughly around 2.4. And for the minus sign, is 2 minus square root 8 divided by 2. We have around negative 0.4. So we are going to do something like we did in our last lesson. We draw the x-axis. Then we have 2 zeros. We are going to divide this x-axis into 3 intervals. So this is f prime equals 0, f prime equals 0. This is x less than negative 0.4. This is x between 0.4 and 2.4, negative 0.4. And this part is x greater than 2.4. So we have this x squared. So we just sub in x squared minus 2x minus 1. So we pick one number. We could just pick negative 1, sub in. Then you will find out you have this is a positive sign. So we sub in 0. We have negative sign here. We sub in x equals 3 here. We have positive. So it means this is our prime. First derivative. So this is increasing. This slope is decreasing. So from increasing and decreasing at x equals negative 0.4, you will see the graph is this way is local max. And x equals positive 2.4, the graph is decreasing and increasing. So at this point, we have local minimum. And if we want to find the maximum minimum value, we are going to sub in the x value to the original function. So fx equals, when x equals negative 0.4, we have 2 bracket negative 0.4 bracket cubed. So substitute it into the original function f at x. Then minus 6 times negative 0.4 bracket squared minus 6 times negative 0.4, then plus 12. Get your calculator out, you will find the y value is 13.3. So this point is negative 0.4, 13.3 is our local max. And when x equals 2.4, we are going to see sub in f at x. 2.4 equals 2 bracket 2.4 bracket cubed minus 6, 2.4 bracket squared minus 6 times 2.4 plus 12. Get your calculator out, you will find out it's around negative 9.3. So at point 2.4 comma negative 9.3, this is our critical point. It has a local minimum. So this is the answer for this question, and on your test, the mark will be given this way. So you find the derivative correctly, 1 mark. You find the 2 zeros for the derivative, 2 marks. Then you draw the chart and find out the local maximum, local minimum, 2 marks. Then you have the value for the maximum, minimum, 2 marks. So altogether 1, 2, 3, 4, 5, 6, 7. So 7 marks for this question. And this is a typical question for finding the maximum, minimum, local maximum, minimum. So you will see that we didn't consider the endpoints. And for this one, we have endpoints at negative infinity, positive infinity. So we just look for the critical points. When the prime equals 0, we didn't consider the endpoint. So this is for example 1. Then we are going to continue to see example 2. So practice more. So we have this function f at x equals x cubed. It asks you if this function has a maximum, minimum at critical points. The critical points definition is a derivative equals 0. Because this is a polynomial function, so we don't have the undefined. So we just need to find the f prime c equals 0. So in order to find f prime equals 0, we need to find the f prime from the given function. So 3, then x degree minus 1 is squared. Let f prime x equals 0, we have 3x squared equals 0. Then we have only one variable x appeared. We don't have two terms. One term only. We can do the isolation by moving numbers to other side, by doing opposite operation of bad math. No adding, subtracting. Then we start multiplying, dividing. Divided 3, we have 0. Then we do the exponent, square root both sides. So x equals square root of 0 give us 0, positive, negative give us only 1 value. So we have x equals 0, then we draw the x-axis here, then we put the 0 here. We only have 1, 0, then it means we divided the x-axis into 2 intervals. So this column we are going to put the f prime x here. So we have 3x squared. Then after it, we determine the f prime is positive or negative. So this is our chart. This is x, the f prime equals 0, x value, you have 1, 0, then you have 2 intervals. You have 2 zeros, you have 3 intervals. You have 3 zeros, you have 4 intervals. So for here is x on the left side of 0 is x less than 0. This on the right side is greater than 0. We just pick a random number. You could pick negative 100. So negative 1 put here, 3 times negative 1 squared give you positive. So the whole derivative is positive. And here we take positive 1, sub in is positive. So you will see the graph is increasing, increasing. If both increasing, it means it will be something like this. So increasing, increasing, both positive. We don't have maximum or minimum at that point. So it will be increasing, increasing this way. From left to right, it's up. So this point, derivative is 0, but there's no maximum. So we are going to say there no maximum or minimum at 0 with sub in 0, 0, 0 point. So that is done. How to find the y value? We sub in the 0 to the original function. So, original function is just x cubed. We sub in x is 0, 0 cubed give us 0. So This is x value, this is y value. So we have 0, 0 points at this critical point. But at this critical point, we don't have the maximum minimum. Then we have a look of another question. This is a rational exponent. So 2 over 3. It asks you same thing at critical point. Do we have the maximum or minimum? So this one f prime of x, we are going to use a chain rule. So we do the exponent first. Exponent minus 1 give us negative 1 over 3, then continue to do the derivative to the base. X plus 3, the derivative is 1. So we have 2 over 3 x plus 3 to the exponent negative 1 over 3. Then we are going to let f prime x equals 0, and we are going to write the negative exponent to the denominator. Flip it to positive exponent. Then you will see when we solve it, we times it to other side. We are going to have 2 equals 0 times anything is 0. Then it doesn't work. No zeros. This is a no zeros, but we have restriction. Restriction is define what x value will make this f prime x undefined. So the denominator equals 0 is our restriction. So denominator x plus 3 to the exponent 1/3 equals 0. So move the 3 to other side. Divide this 3 to both sides. We have x plus 3 to the exponent 1 over 3 equals 0. Then, in order to get rid of the fraction exponent, we cube it. So 3 times 1 over 3 is power rule, give you 1. So x plus 3 equals 0. Then we solve for x, move the plus 3 to other side, is x equals negative 3. And this x equals negative 3 make the f prime x undefined. So that is our critical point. And we are going to draw the chart. So I will draw the chart here. X axis, then we have only one point is negative 3. So this is y-axis, then this is x negative 3 is our critical point. And we are going to find on the left side x less than negative 3. This is x greater than 3. Sorry, I don't need the y-axis. So only one undefined critical points. So only negative 3. So x less than negative 3, x greater than negative 3. One critical point divided the x-axis into 2 intervals. This part is just f prime. So we are going to copy this 2 over 3. This is numerator, this is denominator. So for numerator 2 is always positive. For the denominator, we sub in negative 4. Then you will see this is negative. Sub in positive 0, we have positive. So the f prime give us negative and positive. So it is from negative to positive. It means it's going negative, positive. You have a local minimum. So, and we sub in x equals negative 3 to the original function. F negative 3 equals negative 3 plus 3 to the exponent 2 over 3 give us 0 to the exponent 2 over 3 give us 0. So negative 3, 0 is our critical points, and at this point, it has local minimum. So this is done. And go back, see step 1, we find the derivative equals 0, then we find the critical points. After that, we sub it back to the original function to find the point. So it's negative 3, 0. Then draw this chart to see positive, negative. Then this is a negative, this is positive. So it's going this way. Then you have a local minimum. So this is example 3. Then we just have one more example. So it asks you to sketch a function by using the given information. So sketch a graph of function that is differentiable, so the derivative exists on the interval -4 to +5, and satisfy the following condition. Function is increasing on this part, -2, +3, decreasing elsewhere on this point. So it means if we draw the x-axis, and it will start from -4 to +5, and from -2 to +3, you have the, so I will draw this chart. So this is a so 1, 2, 3, 3 intervals, and here is increasing, elsewhere is decreasing, is negative. So f prime is negative, positive, negative. This is for the first sentence. Then the largest value of f is 5, and the smallest is -1. The graph of function f has a relative minimum maximum at -2, 1. So this is a point. And from here, you will see it will be a local minimum because it will go this way. And 3, 3 is going this way. So it's a local maximum. So this is here. Then it asks you the maximum is 5. Largest value, so it won't be here. It must be somewhere here. It's at 5. So -4 and points. And this one is minimum is -1, so it should be go a little bit here. It's 5, -1. So this is all the information we get from these 3 sentences. Now we are going to move this one here. So we draw the x-axis here. Then from -4 to +5, so we may just draw the y-axis here. Then you will have -1, -2, -3, -4 fit perfectly. 1, 2, 3, 4, 5 for the x. Then -2 and +2, -2, +1. So this is -2, +1 is 1 point. 3, 3 is another point. 5, -1 is this point. -4, +5 is this point. And on the left, all the others here will be increasing. From -2 to 3 is increasing, and the other part is decreasing. Okay, so this is how we do the graphing based on the given information. So increasing slope is positive, decreasing slope is negative, and this is a given point, -2, 1, 3, 3. And here, no way we can go to 5, so this is a end point. This is 5, negative 1. So, and the mark will be given. You find all these points properly, then you graph the trend properly. So 2 marks, altogether 5 marks. So in this lesson, what we have done is we are looking for the local minimum, local maximum by finding the first derivative equals 0 or undefined. We call those points our critical points. And from the critical points, we find out is changing the sign or not. From left to right, if changing the sign, negative to positive is minimum, positive to negative, local maximum. And today's assigned work is Delta Math 4.2. Thanks for watching.